Hey guys, it's Manzanero here, and here we're working on 2003 AB calculus, and here we're on number 82, and this problem here is going to be a graphing calculator required, and so the problem reads, the rate of change of the altitude of a hot air balloon is given by r of t is equal to t cubed minus 4t squared plus 6 from the intervals between 0 and 8. Which of the following expressions gives the change in altitude of the balloon during the time the altitude is decreasing? So basically what this question is asking you to recall what knowledge is curve sketching for the first part, because it's asking the change of altitude when it's decreasing. So the first thing we're going to want to do is we're going to want to plug this function into our calculator. So we're going to plug that in. Alright, and we're going to graph that. Okay, so we're going to make the window fit the function, the intervals that it gives us, I'm sorry. So from 0 to 8. So it's asking you to recall some curve sketching knowledge, because r of t here is, it says that it's the rate of change. So what that basically is the velocity. And since this is a velocity, this is going to be not the original function, but this is going to be the derivative. So to find out when it's decreasing, it's going to be whenever this graph shows that it's negative. So as we can see here, it's going to be negative when it's below the x-axis right there. And so it's asking for the change in altitude while in between those two values. So to find those values, we're just going to hit second calc, find the zeros, alright, so it gives 1 0 as 3.514. So our upper limit will be 3.514. We could just write that down somewhere so you don't forget that, and then you're going to have to calculate the other zero. So, which is 1.572. Okay, so now that we know the interval in which it's decreasing, now we can set up our integral. To find what the change in altitude was during that time. So we would just write out our integral. It would be from 1.572 to 3.514, and of this function, so of r of t. So it would be r of t dt, and that is where we would find the change in altitude. And since it's just asking for the expression, you don't have to solve it or anything. You don't have to plug it into your calculator. All you have to do is write out the expression, which we're going to see is A. 0 to 8 for answer B is wrong, because 0 to 8 is the given interval. That's the time window which is given us for the whole problem. That's not when it's just decreasing. From 0 to 8, it's increasing, then decreasing, then increasing, so that's wrong. And then C is 0 to 2.667. This problem uses the acceleration function. So what this problem did is it found the derivative of r of t, and then it found where it was decreasing. So that's why C is wrong. And D is wrong because it uses the derivative inside of where it's going to be evaluating the integral. So that's also wrong. And then E is wrong because it does the same thing as C. It uses the acceleration rather than the rate of change or the velocity. So that's why the answer is A, because it uses 3.514 and 1.572, which are the zeros and the interval in which r of t is decreasing, and also uses r of t, which is that's just gonna be, you're gonna have to recall some integration knowledge there too. So that's basically how you solve number 82, and your correct answer is going to be A.